In this particular video, we'll be solving this question, which is longest array of ones after deleting one element. So let's read the question. I have been given a binary array which is nums, and I have to delete one element from it, exactly one element from it. So after that, I have to return the size of the longest non-empty subarray containing only ones in the resulting array. And if the subarray doesn't exist there, I have to simply return a 0 in that case. So let's look at some of the test cases here. So I have been given this nums array, which is 1101. So I have to first delete one element from here, and I have to return the length of the longest subarray, which is containing only ones in it. So definitely, while deleting one element from it, I will try to delete a 0 because I want the longest subarray which is containing only ones. So why I will delete a 1, instead I will delete a 0, so that my I can get my best answer, right? I can get my longest non-empty subarray containing only ones. So if I will delete a 1, my length will increase, right? I want to, that's why I will try to delete a 0. And after deleting a 0, after deleting this 0, the array will be 1 1 and 1. So the subarray will be, subarray's length will be 3. So the answer for this test case is 3. So let's look at this example too. I have been given this array, and I have to definitely I have to delete only one element in this also. So if we look at this solution, if you look at this test case, I have few options. I can delete this. If I will delete this, then this is the subarray I will get. Yeah. If I will delete this 0, this is the subarray. This subarray of length 3 and this subarray of length 2 will get combined and result in a subarray of length 5 containing only ones. Yeah. So if I deleted this 0, this subarray of length 2 and this subarray of length 1 will get combined and it will result in 3. So I think deleting this 0 is better than deleting this 1. So definitely I will go with this deleting. Now let's look at the edge cases where every element is a 1. Every element is a 1. So in that case, I will simply return a n minus 1 as an answer, because I have to delete only one element and I am left with I am left with only one possible option, that is 1, right? I have to delete one, that is only one my option. So simply I will return n minus 1 as an answer. So if we think for the solution, for the solution for this question, I can think of a sliding window where I am trying to maintain the count of my 0 value, and I will try to maintain the count such that my zeros count is lesser than or equals to 1. And if it is lesser than or equals to 1, then it is a valid window and I will try to get the length, try to get the answer for it. So let's look at this question, this code which I have coded up. For the implementing the sliding window approach, I will take two pointers, I and j, which are definitely, they are initially at the 0th position, and here j will be moving to the right and it will increase the length of the sliding window. So while moving to the right, it will definitely get 0 and 1. So if I will get a 0, I will simply increase the count of 0, and if my zeros count is lesser than or equals to 1, which is I have written in the else statement. Well, I have written something like, if zeros count is greater than 1, I will do something which I will explain you just a few minutes after it. And if zeros count is lesser than or equals to 1, I will try to get my answer by simply doing j minus I. not j minus I plus 1, because I have to delete a one element as well, right? If I'll do j minus I plus 1, I will get the actual length from including I and including j, but I have to delete one element. So what I will do is that my formula will be, let's see, yeah, my formula will be like this: j minus I plus 1. This is what it will give me, the length of the subarray from including I and including j. Yeah, now I have to delete one element, so what I will do is that I will do minus 1. Now this minus 1 plus 1 will get cancelled down, and the final formula will be j minus I only. So I have written j minus I here. So what if my zeros count is greater than 1? What if my zeros count is greater than 1? In that case, I cannot consider it as a valid window, because I cannot delete two element at once. I am just given permission to delete simply one element from it. So I have to shrink the sliding window and make the current sliding window to a valid sliding window. And this I am definitely going this I am definitely going to do by increasing my ith value. So let's see how am I going to do this. I will explain it. I will explain you here. So suppose this is the test case we got. Suppose this is the test case is like 0 1 1 and 0, and initially my zeros count is simply 0, and my answer value is also 0, right? And I have I and j here. Now this code while loop will run if num sub j is equals to 0. Is it a 0? Yes, is it? It is. So my zeros count will be from 0 it will be 1. Yeah. Now is my zeros count is greater than 1? No, is it? It's not. So I'll move to else condition and I will do j minus 1. I mean I will get the answer. So j minus I is simply 0. J is also 0 and I is also 0. So 0 minus 0 simply 0. Answer will not be updated in this iteration. Now I will increase my j and it will move to first index. Is it a 0? No, zeros count is the same. Is now I will move to this if condition. If zeros count is greater than 1, no, it's not. So I will move to else I will go inside the else condition and I will do j minus I. So now at this position j minus I my answer will be updated, and j minus I is 1, so answer will be updated to 1. Now my j will again increase. Now this is a 1, no effect in zeros count. Same thing, it will again go into else condition and update the answer value. From 1 it will be 2. Why 2? I mean, let me write the indexes 0 1 2 3. Right, these are the indexes. J minus I, 2 minus 0, 2. So now answer is 2. Now this statement will occur and my j value will be here at third index. Now this is a 0, this is a 0, right? And this is not a valid window. I have to make it a valid window so that I can proceed further. I mean uh, I can move my this j pointer, right? So what I will try to do is that I will try to I will try to decrease my window by increasing the value of I. While increasing the value of I might get 0 in between, so I have to uh, take consideration in it take consideration of that as well. So at this position I got a 0, right? So let's look at this while loop, what it is doing. While zeros count is greater than 1, is greater than 1, yeah, Let I think I haven't updated. Currently zeros count will be 2. Yes, from here to here. Is zero count greater than 1? Yes, it is. So I will check if nums of I is a 0. Yes, it is. And zeros count will be minus minus. So I will decrease my zeros count and increase my ith value. Now I will be here. Now the zeros count is not greater than 1. It's equal to 1 and it's a valid window. Now I can proceed further. Suppose like it was this test case was something like let's say 1 1. Yeah. Now my j value will increase. Now after finishing this while loop, my j value will increase by this statement. I will move here and again it's a valid window, right? And again my answer will be updated like this. 4 minus 1, which is 3. Answer will be updated to 3. Why 3? I can simply delete this 0 and this will be concatenated, right? I mean this, the length of 2 and the length of 1 will be added and I will get a length of 3. Now again j will increase and move to here. Again it's a valid window. Why? Just because the zeros count is lesser than or equals to 1. Yes, simply I will update my answer here as well. So j minus I, 5 minus 1, that is 4. So I hope you got the solution. Thank you.